Hello, friends. I'm going to give you a brief overview of this Dig Deeper research project you're going to be doing. It's a paper. If you've looked at the assignment, you can see that it's going to be at least a 3-page Google Doc, single-spaced, all the great formatting that you're going to do. But what is this actually that you're going to be digging into? There is a document that I've referenced in the assignment, and it looks like this right here. What is this? This is a report that came from the Imperial College of COVID-19 response team in England. So what they did back on March 16th is they released this report, and President Trump and other world leaders have been using it to dictate what the action plan is. Let me know if you have any trouble downloading that document, and I will help you out with that. So what are we looking at here? This is what we're looking at currently. We've got, as of March 23rd, I just pulled this off yesterday. Today is Tuesday when I'm recording this, but yesterday we had all 50 contiguous United States reporting cases of the COVID-19 disease. So some states, including our good old Michigan right here, are 1 to 5,000. That's probably changed already today. I think it was almost 4,000 as of yesterday. So we can expect those numbers to go up. So we're going to be looking at what are we going to do about it? What do we need to know? What do we need to learn? Here's some lingo that you need to know about. Number one, this one right here. This is going to be referred to several different times in the document. It's called the R-naught. You may or may not have heard that before. It's a statistical term, and it stands for the reproduction number, or the number of people that each person could themselves contact. Right now it's predicting 2.4 to 2.6 is our R-naught. That means for every single person that's infected, they would infect at least 2 others. So this is what it looks like in a picture format right here. Here's my one person. Let's say that it's me. And I cough and I infect 2 people, and those people go ahead and infect 2 people, and you see how this is going, right? So what are we also going to be looking at here? We're going to be several times you're going to see NPIs, or non-pharmaceutical interventions. So these are just non-drug ways of curbing the disease. So what we've been doing lately, so the social distancing, the wearing masks when appropriate, which is actually not appropriate for anybody unless you're actually infected, wearing gloves, shutting down the schools, quarantining the sick. Those are all termed NPIs. This table right here is from the document itself, and it tells you a lingo as to what these NPIs actually are. They're going to refer to CI, case isolation at home. That is for people who have actually been diagnosed, right? HQ, voluntary quarantine. So you come into contact with somebody, you're going to stay home. SDO is that social distancing of people over the age of 70. SD is just social distancing that we've all been doing. And PC is the closure of schools and universities. So these are the NPIs that they talk about in the paper itself. And there we go. So you can see the bottom of that. Take a look at the next one. Next terminology you need. They use GB a lot because the paper was written and the study was conducted in England or Great Britain, so that's what GB stands for. They also refer to us, the United States, in there. And then exponential growth rate. You probably are familiar with that if you took any math class at Everest, because I know in Providence Stats, I'm sure Mr. Stencil has told you all about this. So what does this look like, this exponential growth rate? And is that even what we're talking about here? Yes, we're going to do a little bit of math. So I'll show you the actual math part of it, but this is what an exponential growth curve looks like. It means this keeps on growing and growing exponentially forever. And is that even a possibility with a disease? No, because it would assume that we have an unlimited number of people to be infected, and that is not in fact the case. So we're going to talk a little bit about that when I show you one of the resources that I have for you. Take a look at the math. Oh my goodness. So yeah, you know that I don't math, but that's okay. We're going to take a look at this particular website, and it is linked for you in the Google Doc of resources that I provided for this assignment. So let's take a look at this explanation for the math of what everybody's talking about. So I'm going to this website link from Wired, and it talks about the math behind flattening the curve. That is a term that we've heard about over and over and over and over. There is the math. If we're going to run this simulation here, you put a formula in here. You can change the parameters in this formula if you want to. I'm personally afraid of math, so I'm not going to, but I'm just going to show you what they have for you here on this website. So it shows that, click it along here, this is showing an exponential growth curve at first. So days, right here, let me pull this down so we can see it better. There we go. The number of people infected, you can go scale up and down here. It shows you in the thousands and over the course of one day. And this is if you assume the rate of infection is only 20%, and it's actually much more than that. So taking a look at real data, these are data points collected from China, France, Iran, Italy, South Korea, and us here in the United States. So we obviously have much more data on China because they've been battling with this since early December. And then these other countries are chiming in kind of late in the game. So what is this showing you? This is showing like an S type of curve right here. So it looks like we had this exponential type of curve going on right here. And then it leveled off a little bit. And then we had a small little growth. And now it's leveled off up here. There we go. In China. We can do the same for the other numbers. We can just click on it and show what are the numbers, what's going on right now. The US, we're pretty low because so far we haven't had that many cases, but that's going to grow. So the person who wrote this said that they made the graph a week ago. Now in China, their data points are still going to be the same because they've leveled off. They've started to come over on the other side of this because they've been battling it for a while. But now we're looking at adding all these other data points for these other countries. So governments take a look at this information and they don't just sit around and say, oh, that's so awful, that's terrible, oh my goodness. So what are they doing? They're quarantining, they're limiting travel, we're having these lockdowns, we're doing things like that. So let's take a look at, there's this logistic function. We're looking at a logistic curve actually rather than an exponential one. Why? Because you don't have an unlimited number of people. The number of cases isn't going to keep growing forever and ever and ever because eventually everybody's going to be either infected and recovered, infected and not recovered, which means that they die, or they're not even there, right? So you're either going to have this eventually or not, unless you're living on a completely isolated, deserted island, which doesn't apply to a whole lot of people. So let's take a look at this curve. This is actually a better curve for what we're looking at for this disease. It's called a logistic curve. And if we apply the parameters over to the left that this person has done, we see that the number of people infected, so this is to the fourth power, right? And we're seeing that there is a leveling off. This is what we're talking about when we're looking at flattening the curve. We'll talk more about that in a second. So over time, we want what's going on right now exponentially because we're infecting a lot of people, a lot of new people, right? Where that's going to level off as we kind of reach our saturation point of infection. So flattening the curve, what does that mean? There's a question in your assignment that refers to this, and this is a perfect website resource to start your understanding of that, but then you're going to need to dig a little deeper, hence the name of the assignment. So what does flattening the curve mean? There are two different approaches. So if we're doing what we're doing now, which is sheltering in place, we've created now two curves. And we want to extend, here's the key right here, the number of people that are going to be infected is exactly the same, folks, right? We're all going to probably be in contact with this disease at some point. Most of us, a good portion, probably around 97% are going to recover and be absolutely fine. But the problem is we only have a limited number of beds, right? A lot of these cases, especially if you're immunocompromised or if you're elderly, if you're very, very young, you need to have either ICU, that's intensive care unit attention, or at least hospitalization for probably 8 to 10 days. Again, you're going to read your document and see what they're talking about there. What we want to do is spread out the time that hospitals have to answer this need, right? So instead of at day 20, oh my gosh, all of a sudden we've got all these people becoming intensely sick and needing care, now we've lengthened that time out to day 30. So we're giving them a bigger window, this 10-day time to get people better, to get them out and to clear out hospital beds. So what we're doing is we're lessening or decreasing the huge spike of impact of people getting sick and helping those in the healthcare industry kind of spread out the number of people who are going to need beds no matter what happens out over a longer period of time. I hope this is making a little bit of sense for you. You're going to read this on your own, though. That's why I'm blasting through it. So here we go. Ha ha ha. So now we've got two peak curves right here. This is the one that we're looking at shooting for. We want to lengthen the amount of time the hospitals have to prepare. We want to also lessen the impact that they have for their peak time. And when you look at your document, you are going to address that. All right. So tips for you as you go through this assignment. Number one, you're going to look at the document at least twice. It's difficult. It's a primary source, right? So it's not going to be written in layman's terms like that website just was. So there are resources I've given you that are written in layman's terms. It's not that you can't understand this document. It's just going to take you a little while to do it, but it's really worth the time. It's a good primary source, and it's practice for higher level thinking. You'll be definitely doing it at least once or twice in your lifetime in the coming years, right? So a couple of tips for you. A lot of statistical terms are going to be thrown around in the document. Just move past those. If you understand them, that's awesome. You math way better than I do. And some of them will make sense, some of them don't. Don't get stuck on those. If you don't understand some terms, don't spend a whole lot of time looking different statistical things up because they're going to give you a summary of what they're talking about. And you'll be able to get past all that. Read it through at least twice. And it's kind of a long document. I think it goes through 16 pages total, and then you've got some references at the end to show you that it is a valid document. So you're going to need to take a little bit of time with it. Go back and highlight, do some things like that. All right, here we go, folks. You're going to want to pull up that document, right? You guys are smart. We're going to dig a little bit deeper on this. And this is going to be a thing that is going to disappear. We really will battle it. We'll come out better on the other side. Yes, it's going to take some prayer. It's going to take some patience. It's going to take some truth. That's why I'm having you do this assignment. It's going to be one of the only assignments you have for fourth quarter because in a couple weeks here, we have to start getting you ready for taking the test, right? And then that's kind of the end of the class. So we'll talk more about what that means later, but this is really it. I really want you to dig into deeply to this. Let's eradicate this disease, right? Let's completely wipe it off the map. In order to do that, we need to fight it with truth, love, and understanding. So that's it for the explanation. We'll have a Zoom conference so you can ask all the questions and voice any concerns that you have. But take a look at the assignment online, and it's in Google Classroom just like everything else right now. And let me know if you've got any questions. Love ya.